Hello again, back with the prerequisite skills number 2 screencast for Unit 4. Going back to factoring trinomials now for example 2. So example 2, we have factor x squared plus 11x plus 24. So if you recall, our steps are to identify A, B, and C. So A, B, C. A is 1, B is 11, C is 24. So I need two numbers that are going to multiply to 24, make a list, and add to 11. So let's see, 24. We have 12 times 2. 12 times 2 is 14, so that's not going to work. We have 6 times 4 is 24. That adds to 10, so that's not going to work. 8 times 3. When we add those up, we get 11. So there are factors, 8 and 3. So to factor x squared plus 11x plus 24, that equals x plus 8 times x plus 3. And here is the factored form of that trinomial. Again, we could have used area model. Area model would have the 4 boxes. The first term x squared in this box, the second term, or the last term 24 in the box diagonal. And these are your x terms, which we have to fill in, so we don't know what they are. But we know to make x squared, we would need an x and an x. And then we would guess and check for 24. So we could guess, if I started out like I did in the over here, I would have started with 12 and 2. So this would be 2x and this would be 12x, and 12x plus 2x is 14x, which I need 11, so 14x is not going to work. So erase that, erase the 12 and the 2, and try something else. If I did the 6 and the 4, same idea. This would be 4x, this would be 6x. 4x plus 6x is 10x, and again I need 11, so that's not going to work. And you would do the same idea, continuing with that. It's just a different way of looking at it. So then here's the 8 and the 3, here's 3x, here's 8x, and I end up with 8x plus 3x, which is the 11x. I already have the x squared and the 24, so I know that when I expand that, I'll get the trinomial. So I'd put this one in parentheses, add it together, and this one in parentheses, add it together, and I end up with the answer that I had before. So let's do example 3, but let's do example 3 now by just doing the area model before we do the other way, just to kind of switch it up a little bit. So example 3, we are factoring. So factor x squared plus 4x minus 12. So let's say I just want to go with the area model. So here's my box, here's x squared, here's negative 12, and I need to figure out what's going on the outside. So I know for sure that this is going to be an x and an x, so I can start my parentheses with an x and an x. Now, how could I make negative 12? Well, I can make negative 12 by negative 3 and positive 4. So that would make this negative 3x, and this would be positive 4x. And when I add those like terms, 4x plus negative 3x, that gives me 1x. Now I'm looking for 4x. So this is not going to work. I need to erase and try something else. How about, what makes 12? How about 6 and 2? So here's negative 6 and 2. So 2 times x is 2x in this box, and negative 6x here. So negative 6x plus 2x equals negative 4x. Well, I'm close, but I need positive 4x. So what if I just switch my negative? If that's not positive, and instead my 2 is negative, that gives me 6x plus negative 2x, which gives me the positive 4x. So my parentheses would read x plus 6 is one set, and x plus negative 2, or x minus 2, is my other set of parentheses. Okay, and that's just going off the area model. You can, of course, just do factoring, which I'll do an example for. You can just do the algebraic way here. So factor x squared minus 19x plus 90. So I'll label, here's A, B, C. So A is 1, B is negative 19, C is 90. So I need to multiply to 90 and add to negative 19. So 90 right away, what comes to my mind is 9 times 10. 9 times 10, when I add those together, I get 19. But I need negative 19. Well, what if I have negative 9 times negative 10? When I multiply two negatives, I still get a positive answer. So negative 9 times negative 10 is positive 90, and negative 9 plus negative 10 is negative 19. So there are my factors. That one works out, this one did not, and I end up with x minus 9 and x minus 10. Okay. So what if a, that first number in our trinomial, what if that is greater than 1? Well, then it becomes a little bit trickier. So we can still use the same type of method and guess and check. And it's going to be a little bit more complicated because now we need to multiply with the x squared term. So in the first example, in this category that I have for you on your handout, it says factor 6x squared plus 31x plus 40. So now when I'm looking for factors, the area model really comes in to help here because I not only need numbers that multiply to 40, I also need numbers that multiply to 6. And then together, all of these numbers are going to add to 31. So the whole idea of the area model is that it keeps everything together. So I'm going to just list some factors of 6. So I have 3 times 2 and 6 times 1. And I have the negatives also. If I need them, I'll go to them. Okay, so 40, we have 10 times 4. I have 20 times 2. I have 8 times 5. Anything else that we can think of off the top of our head? We'll just leave it at that for now. Okay, so I'm going to draw a couple of little area models and see what we can get. So I'm going to start with this factor pair for 6x squared. So this is 6x squared. This is 40. And I'm trying to figure out what is going to go here and here so that when I add those two up, I get 31x. Okay, so I need numbers here, 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 and here. So I've listed my pairs out. I said I'm going to start with 3x and 2x because 3x times 2x is going to give me that 6x squared. Now I have to look for pairs of 40. So I'll start with my first one here, 10 times 4. So if I put in, here's 10, here's 4. Now it doesn't matter if it goes on the side or on the top. I could have the 4 up top where the 10 is and the 10 over where the 4 is. That's not going to make a difference. So when I do 10 times 3x, I get 30x. And 2x times 4, I get 8x. And when I add 30x and 8x, I get 38x. Not the 31 that I was looking for. So this one is not going to work. So back to the drawing board. Okay. 6x squared. I need to fill those in. Here's 40. This is here, 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 and here. I'm going to stick with the 3x and the 2x. And I'm going to try that one out. If we put in the 20 and the 2. So 2 times 2x is 4x. 20 times 3x is 60x. And 60x plus 4x is 64x. That's definitely not going to work, so that guy's out. Okay. Let's try. See how annoying this is? This is not really fun. It was fun for a little while, but this is definitely not fun. So luckily, after I make you go through all of this, I have another way for you to do it and be a little bit quicker. All right, so I'm going to stick with the 3x and the 2x, and now I'm going to try the 8 and the 5. So I am going to put 8 here, 5 here. 5 times 3x is 15x. 8 times 2x is 16x. And 15x and 16x is 31x. So here I have, let me erase these other guys, get these out of the way for a minute. So here I have my answer. I'll have 2x plus 5 and 3x plus 8. And that is the factored form of 6x squared plus 31x plus 40. Now that's using the old school and the area model. We have another way, which if you flip the page, go to that last page, it talks about the Xbox factoring, which is just cool because it sounds like the video game on top of being a really easier way to factor. So let's try factoring the same thing, 6x squared plus 31x plus 40, which isn't the easiest thing to start with, but why start easy? It's not going to stay easy, right? So let's factor this using the Xbox method. So this is Xbox. Okay, and it's called Xbox because it uses an X and it still uses the area model. But the X throws a little bit of something different into it. So we start with an X and we draw the area model. So I'm still going to fill in the area model, 6x squared and 40. I still am going to wait to fill in the rest of this until I fill in my X. Okay, so the X box says take your A and your C and multiply them together. So A is 6, C is 40, 6 times 40 is 240. And then take your B term and just put it down here in the bottom of the box. So this is 31. So now to fill in these two sides, you're going to have two numbers that multiply to 240, that top piece, and add to 31. So still the same idea. 240, that's why I said this is not an easy one to start with, because 240 obviously has a lot of factors, but we can go through, try them all. Since we already did this example, we already know that this is 15 times 16 is 240. And no, I don't know that off the top of my head, but you grab a calculator if you need to, if a number's high enough like this, and just start messing around, get some factors, make a whole list. I originally on my notes had 10 and 24, 8 times 30, 12 times 20, but because this is the example, I want to kind of keep it short, 15 times 16. And when we add 15 times 16, we get 31. So what do we do with those numbers? Well, this becomes 15x over here, and this is 16x over here. And then these two numbers are what go in our box. So here's 15x, and here's 16x. And again, it doesn't matter if the 15x is over here and the 16x is here, or vice versa. It doesn't matter which box you put them in. Okay, so now what do? Well, we bring back that whole idea of the greatest common factor. So what's going to go over here is the greatest common factor between 6 and 16. So 3 doesn't go into 16, 2 does. So this is going to be a 2. And the greatest common variable, we have x squared and x to the first, so we can pull out an x. Same thing on the bottom. Take out greatest common factor, greatest common variable. There's no variable in common. The greatest common factor between 15 and 40 is 5. Okay, so now to fill in the top spots. Well, now I ask myself, okay, 2x times what is going to give me 6x squared? Well, 2 times 3 is going to give me 6, and x times x is going to give me x squared. Over here, 16x, 2 times what is going to give me 16, that's an 8, and x times what is going to give me x, well that's going to be a 1, so I don't write that in. Now, I just want to check that that works with my bottom part of the box. 5 times 3x is indeed 15x, so that works, and 5 times 8 is 40, so that checks. It's a nice double check. And now, here is my factored form. 2x plus 5 times 3x plus 8. And if we go back to the other screen, oh, where'd it go? Did I erase it? Did I not do it? I erased it. Darn it, that was silly of me. Anyway, if you go back to your notes, do it that way, you'll see that that was the same exact answer we got when we did the regular old factoring. And this time, yes, it might have been a little bit more drawing, but you'll get the work a whole lot easier. And again, this is a harder example because the numbers are bigger. Let's do the last example that we'll do now, and then we'll try them when you come to class. So example 2, we're going to factor 4x squared plus 2x minus 12. So here's my x, here's the box. Fill in the box first, so here's my 4x squared and the negative 12. I'm going to need to figure out what's in here, and then I'll be able to fill out the outside. Okay. So, what do? A times C. So, let me switch colors here. Here's A, here's C. 4 times negative 12 is negative 48. Take B, put it in the bottom. Here's a 2. So I need two numbers that multiply to negative 48 and add to 2. So when I see 48, I automatically think 6 and 8. I need negative, so if I have negative 8 times positive 6, that gives me negative 48. If I add those, I get negative 2. So that doesn't work. But I have the number that I need, just not the sign, so switch the signs. Negative 6 times a positive 8, when I add those, I will get the positive 2 that I need. So there are my two factors, negative 6x and positive 8x. So I'll come over to the box now, put those in, and now we factor out the greatest common factor and the greatest common variable. So moving here, going across, 4 and negative 6, greatest common factor would be a 2. Greatest common variable, x squared and x to the first, we would only be able to take out a single x. On the bottom, 8x and negative 12. Here we can take out 4 is the greatest common factor, and there's no greatest common variable because the 12 does not have an x. So let's do the top. How would I make 4x squared? Well, 2 times what would give me 4? That's a 2. X times what is x squared? That's an x. 2 times what would give me negative 6? That is a negative 3. And x times 1 would give me x, so I don't need to put that in. And now we check the bottom. 4 times 2x is 8x, so that checks out. And 4 times negative 3 is negative 12, so that checks out. So I have now factored this trinomial into 2x plus 4 times 2x minus 3. And there is the factored form there. So I know this looks a little bit confusing, it looks kind of crazy. Go back and watch it again, maybe Try to do one of the first ones we did with a being 1. This will still work if the coefficient of a is 1, like the first couple of examples that we did. Try it out, and when you come to class next, we will definitely do a whole bunch more examples. See you then.